So before we start, there are some items that we need to define first. So first, the poles. Poles are the roots of the denominator of the transfer function. And we also have the z-plane. So z-plane is the complex plane for the z transform. So we have to continue the example. We have the example number 2 rather. So we have x of n equal to negative a. X of n is equal to negative a to the power of n u of negative n minus 1. So determine the range of values where the unit step is existing. Let's remember to note that u of n is equal to 0 for n is less than 0, and it is equivalent to 1 for n is greater than or equal to 0. So by shifting, so for u of negative n minus 1, we can define that it is equal to 1 for n is less than negative 1. And u of negative n minus 1 is equal to 0 for n is greater than or equal to negative 1. So with these ranges, we can use this to calculate the z transform of x of n. So z transform is equivalent to the summation of x of n times z of negative n. So now we'll substitute the value of x of n. So we have negative a to the power of n u of negative n minus 1 z of negative n from negative infinity to infinity or so substitute the range of values where the unit step is existing. So we have a summation of negative a to the power of n z of negative n from negative infinity to negative 1, because these are the values that the x of n is existing. So we let m is equal to negative n. Therefore, at n is equal to negative infinity, then our m is equal to 1, and n is equal to negative 1, our m is equal to infinity. So the summation of negative a to the power of m z to m, where m is equal to 1 to infinity. So substituting the value earlier. So we have the summation of negative a to the power negative 1 z to the power all over m from m is equal to 1 to infinity. So Recall the geometric series, the sum of the geometric series. So A is the first term and R is the common ratio. Where n is equal to the number. So substituting that, we'll have negative a negative summation of a negative z to the m is equal to 1 to infinity. So we have 1 as the first term, 1 minus a negative 1 z as the common ratio. So this is the z transform of x of n. 1 over 1 minus a negative z. Don't forget the negative outside. Or we can write negative 1 over 1 minus z over a. So to get the region of convergence, we must not let the denominator equal to 0. So therefore, 1 must be greater than z over a. So therefore, the absolute value of a must be greater than z, or z is less than the absolute value of a. So that is the region of convergence and the z transform.